Hey, good morning, Dabblers. This is Kale Moody here, community manager at Dabble Club. I've got the man, the legend, and the myth himself, Guru Devrel Mel. What's going on, Mel? Today is our first day of our newest Dabble Club DevCamp, and we've already got slides here. I'll pull us up here a little bit bigger first so we can just say hello and good morning. What are we learning today, Mel? I'm ready to dive right in.
So yeah, thanks everyone for joining. Thanks Kale for joining as well. This is our first session for the DevCamp Onchain Fundamentals edition. So as the name implies, it's going to be a lot about the first steps that you're gonna be probably taking, or some people that might have been working around dabbling with some of blockchain, fun transactions and just playing with NFTs, playing with tokens. But if you're now in this stage where you want to move from just being a user into a little bit more understanding what's happening under the hood, and even get your hands dirty with some code and start building solutions, that's what we will be starting with today. So yeah, it's going to be, I'm not going to get ahead, but yeah, it's going to be a lot about getting your first steps into the ecosystem. We're going to be doing a lot of, you know, baby steps at the beginning. In this session, we're going to be understanding what a blockchain is, what smart contracts are. We're going to be setting up our wallet for the first time if it's your first ride, getting some test tokens and building a very basic smart contract just so you can kind of get your feet wet. Of course, we will be seeing what this whole dev camp is about and what you can expect from us. So it's a great time for beginners. Like, it's a great opportunity for beginners for sure, and even for people who it's their first time, joining, or not the first time, but doing first time code. The whole point of these dev camp is for you to create, have an idea, come in with an idea that you want to build, keep it simple. It's going to be very payments or real world assets focused. Want to get you into this kind of idea of that you can build any kind of payment solution or tokenize any real world asset, which are currently the major use case for blockchains, and for you to be able to code this on a smart contract level and integrate it with a front end, also, and even deploy it live. So you can show it to your friends, you can show it to your family. You can even, if you're there, I would suggest you can also start a hackathon after this dev camp. You can start looking for co-founders. Who knows? This is just the beginning, and it's a lot about exploring and discovering this new world, especially if it's your first time with on-chain or with blockchain technology. And after that, just taking it where we want to as part of our idea. We will be exploring smart contracts in the real world. We will be integrating with smart contract solutions that have a lot of use, such as Uniswap, Circle. We'll be exploring some payments, what's called patterns, or payment solution that's been developed by Coinbase also, which is like very new, and just like getting ourselves used to working with smart contracts on a very basic level, integrating them with our front ends, so you can start building cool stuff at the end of the course. Yeah, I just want to get with that intro. Kale, I don't know if you want to like.
I don't have fancy slides with me today. That's all on you today, Mel. But yeah, if you don't know me, I'm the community manager here at Dabble Club. My job is to essentially support all of the social side of things and keep everybody happy, healthy, and fed, and just make sure that all the questions are getting answered, make sure that the content's hitting the right spots, and making sure that you guys connect with each other. So there was an application included with the kickoff of this dev camp. If you don't have that, I'll drop a link here in the comments here soon and get that shared so you can get that application filled out after the fact. One of the things I'm most excited about is after today's session, we'll be starting to go through those applications and figure out who has volunteered to be linked up with other builders. And we'll start putting together these little work teams and these little work cells, so that way you guys can collaborate and support each other on this journey.
Awesome. Yeah. Thank you, definitely. And yeah, let's start with the slides. So Kale already introduced himself. My name is Mel. I'm lead DevRel engineer at Dabl Club, and I will be your instructor during these 4 weeks. So this is the Onchain Fundamentals edition for the Dev Camp. We're going to embark on a journey to understand blockchain technology, especially focused on Polygon and EVM compatible environments. We will be using Solidity heavily. It's a 4 weeks program. Each week is structured under 2 curriculum sessions that are live, such as this one. It's going to be held on Tuesdays and Thursdays. One office hour session, which is going to be a little bit more about going through the exercises or the challenges, as you can see. Challenges, we will have 2 technical challenges per week, 1 social and 1 community challenges. And this is a course that is taught for absolute beginners and people who have some blockchain knowledge or even Solidity or JavaScript knowledge, as little or as much code that you know already. This is the course if you want to build your first application or decentralized application. We're trying to move towards just app. But yeah, if you want to build your first application integrated with smart contracts, deployed on a live blockchain, a testnet, or even mainnet, this is your opportunity. We will be speedrunning a lot of the content, so there are going to be some concepts, some information that might be too fast for us to take on during the live sessions, such as this one. So the live sessions will be usually between 1 and 1.5 hours. We try to keep the last 30 minutes for questions, exercises, or just some debugging that sometimes happens. But usually we'll try to keep it under 1 hour. We will be publishing some complementary bite-sized content that will help us understand other concepts. We'll work through some, more technical stuff that can be shown on a workshop better than on a live session. Also, GitHub repositories, we will have one for code and one for the content. We will be updating this weekly, so stay tuned. Right now, the content's not up yet, but I will publish it between today and tomorrow, so you can start sharing your technical challenges. And the challenges will be done this way. The technicals will be a PR, a pull request on GitHub, so you will need a GitHub account for this. And the social and community challenges will be posted on social media. Most of them will be all about, sharing what you're learning, sharing what you're building, getting some feedback from other members that have also joined the Onchain Fundamentals course, and just having fun at the same time and establishing these contacts or these connections that can, eventually lead to a job opportunity, lead to a team in a hackathon and winning a bounty, just knowing someone in another city and eventually meeting them, which is something that happens a lot in Onchain or in Web3, and we really want to encourage that. The curriculum is going to be structured under these 4 weeks. So week 1, we're going to speedrun blockchain fundamentals. This is going to be this session. Then we will upload the project setup instructions. So on the second session, which is on Thursday, we will help you get ready to deploy a live application with a smart contract connected already to the a smart contract deployed on a testnet and connected to your front-end application, so you can share it around. It's going to be having a live URL, so you can share it with your friends, your family, like I said. And this is going to be your main project where you will be working on your idea. That's the very important part. We need your idea to begin with. That's part of the application process, because we will be building this idea. On week 2, we will take some real world smart contracts, and the real world is double play in the sense of the words, like real world, as in they exist already and they are being used heavily. We will be using tokens such as USDC, other stable coins, and maybe even some of their SDKs and APIs, so you can understand how we can mint more USDC. You can get some functions that are available with USDC. Also some patterns that we will be seeing, such as vaults, of course, ERC20 and ERC721 tokens, which are probably the most used patterns for tokenizing assets, either coins or tokens, fungible tokens, or NFTs. And with the yield vault generation, so you can start generating yield on smart contracts with USDC or any other token that you want. And also using Uniswap to enable some swaps inside the smart contracts and with your application. All of this is going to be happening front end and smart contract level. Week 3 is going to be a little bit more heavy on the front end. We're going to vibe code front end like a pro. Vibe coding is just, it's a term that's associated. We will be reviewing our code. We don't think that we're just going to be pushing it. That's something that's very fun, but we want you to understand a little bit better what's happening when we are vibe coding. So we will be taking it step by step. And this is also going to help you not only understand at the smart contract, the language, the solidity, the syntax, and all of the code, but also on the front end, we will be, this is not a full coding bootcamp or anything, but you will be starting to get some sense on how to use AI to start building stuff that will be helpful for you, and how to use AI to learn while building. That's going to be the week 3. We will be focusing a lot on account management, on transaction management, on building a nice app that's going to actually be helpful, not only the components for during our course, but you can reuse these components eventually. That's part of the week 3. And week 4 is going to be a lot of more about deploying the smart contracts, verifying them on chain, getting them ready for actual usage, and helping you how to build a demo for your idea, for your app. So it's going to be a little bit more growth-like and helping you on a front end and builder like experience, like a founder, start thinking how to show off your idea, how to show off your demo, and just deploying it live and having it ready for judging. So we're going to start with the first announcing the challenges. So the first one that we want you to start working on already is telling everyone your idea. We're going to ask you to publish an image of your one-liner and how does it work. And I'm going to show you very quick in a bit what do I mean by that. The technical challenges will be first an evidence of your environment setup. So you will need to set up your environment and upload your code, and we will just check that you can actually deploy, use that code, and it's actually running the application and the framework that we will be needing, which is going to be Scaffold ETH2 for this DevCamp. And the technical challenge number 2 is going to be this, what we are going to work on next session on Thursday, which is going to be a smart contract deployed on a testnet. Well, you will have to make sure that this, of course, smart contract is deployed on your behalf, like you're going to deploy a smart contract. And also you're going to deploy your application with Scaffold ETH2. You're going to deploy it to Vercel. It's actually easier than it sounds. And we will go through this next Thursday. And the social one is just going to be sharing all what you learned this week, tagging us and Polygon, of course. And ideally, if you want to share your live URL also, so people can start checking out your application, at least even if it's empty, if it's like the very first draft, that's the idea. We have to be shipping, we have to get out of localhost and making sure that everyone sees that we're building in public. So what's the challenge? And I'm going very fast through this, like this is getting started for the Onchain fundamentals. But the first challenge is going to be your idea. And this is an example of an idea that I love to see somebody build. It's cash remittances sending between United States and Mexico. It's just sending cross-border payments, and you can earn money for each fulfilled transaction if you send money or if you fulfill on the other side. You send money from Mexico to the US or US to Mexico, and on the other side, you fulfill this payment. You get a reward as well as the one who sent it. It's a little cashback. So the idea has to be simple to understand, has to be easy if I tell this to my mom, she probably can tell somebody, some of her friends, like, hey, my son's building a cash remittances app. Okay, that's not hard to understand. It's just like something that it's on a day-to-day use. It can be a peer-to-peer payment solution. It can be universal payments. I don't want to say universal, but accept any currency on your point of sale system. That would be very cool if I could just come and pay with pesos, which is the Mexican currency in Europe, and I can just get. This also already happens with the cards, but it charges like a high commission. So you can do this kind of transmitting your benefits. Like in my case, I'm transmitting that I'm earning, or the users will be earning for each transaction. But it has to be simple to understand. Like if it's not simple to understand, that's part of the whole thing. Like you share your idea and you get feedback on it. And then we start working on a simpler idea that you can probably build in 4 weeks, starting with also like all of this learning. So this is the first challenge. You can start thinking on it. The idea is to have it ready by Friday. Everybody has to send, and make sure to tag Dabl Club and Polygon. And we can, we will be sharing more tips and more ideas for you to start completing this first challenge. But yeah, so that's the beginning. Kale, I don't know if you want to come in and
I'm trying
share a little bit.
I didn't come with an idea, so I'll have to get to my homework tonight and figure one out. I'm wondering, do you have any particular like track or like focus area that you're hoping these ideas kind of limit themselves to, or kind of just let people run wild with it?
Yes, mostly on payments and real world assets. That's what the whole on-chain fundamentals DevCamp is going to be centered around. We're going to see how to use ERC20 tokens, stable coins. We want to really see a lot of you building on stable coins and building on real world assets. If you want to tokenize real estate, you want to tokenize Pokemon cards, we want just to see you making something that you can easily try with your friends, send some money, send some like tokenize the cards, like I said, attestations, or not even attestations, but that's a little, we're not gonna see attestations, but that's also an idea that you could build, like just tokenizing certificates, tokenizing just things that could enable automation and easy payment online, mostly focused on stable coins and real world assets. That's what we really want to see. But hey, if you have any idea that's actually fun and you think that has potential, that's part of it, right? Share it with everyone, and we will give you feedback, and you can start working on that again.
For me, I lean into the real world assets because it seems like a underdeveloped sector right now. Everyone talks about Courtyard.io and the tokenization of physical trading cards. It's a good example, but that concept applied across a whole industry of options. I got some ideas here, Tardan.
Awesome. And yeah, for staying up to date, of course, follow Dabl Club on social media. We would suggest you to join our Telegram channel and just enter dabl.chat. That should redirect you to our Telegram channel. And just also start creating a GitHub account if you don't have one, because we will be requesting your the challenges, the technical challenges, to be submitted as pull requests. So you can get started on that already. So that was the intro to our on-chain fundamentals, and we will head on into the content, the basics. It's gonna start very not slow, but some theory. We will be exploring the blockchain. We will be going through some history of why we're here, and we will be moving into more interactive playgrounds, so you can understand better how blockchain works, how signatures work, some cryptography. We're not gonna dive into the technical side of that, just so you understand what's happening when we apply cryptography to the blockchain and why it's called cryptocurrencies and why we all love this, the power that it comes with that. And after that, we will move into the technical side, deploying a smart contract very easily in an IDE. It's going to be like a very simple implementation of smart contract. And just to get you a little familiar with what we will be seeing during the extent of the DevCamp. So basics, Bitcoin and blockchain. That's the grandfather, no, what we call. That's how it all got started, at least on the blockchain side. So Bitcoin was the first blockchain and also the first cryptocurrency. It was published as a peer-to-peer electronic cash system using cryptography, and the whole thing that it really enabled, it's enabled the decentralized transactions. So decentralized finance. It was the first store of value or asset that was completely decentralized. It isn't controlled by anyone. It's distributed in a network of computers, and that's where it runs. And it was just pretty much this first major application of blockchain. And I place here a small image of how it would look when you hear blockchain. It's a little of a visualization of what a blockchain actually is. So it's a chain of blocks that contains data. And in the case of Bitcoin, what they did was just link transactions. So it's just a way to understand different, like a ledger system that keeps the balance of everyone's current accounts or the balance of on Bitcoin and all the transactions that you make between them. So I mean, I don't want to stay along a lot here. It's just the first one that was created. And Bitcoin uses a proof of work consensus system. We can take a lot of time talking about Bitcoin. It's very fun. It was really, I really suggest you to read the white paper if you have a chance, because it's actually quite short and it's a nice read. And it's also fun to see how this publication of 8 pages or 9 pages, I don't remember, back in 2009 came and revolutionized the world, because it is happening. So that was the first blockchain. And then the one that we're going to be centering on is on the Ethereum ecosystem, which is envisioned as a centralized world computer. So basically, the same idea of a distributed network of nodes that hold the information of the balances as it was happening on Bitcoin, or of transactions, where you can keep track of who has what in a decentralized manner. Well, imagine that you can actually, on top of it, distribute a whole operating system, and we all now not only share the storage part, where we have the accounts or the balances of each user, but we also have data that's available and computational power on top of it that we as users can access to it decentralized. So this smart contract layer, this execution layer, this virtual machine, this operating system that's running on top of this decentralized network enables smart contracts. So we're going to dive a little bit later into the smart contracts. That's the whole idea. But Ethereum, basically what it happens, it evolved blockchain by adding this layer of programmability on top of the decentralization of the storage or the information. And this enables it enables us to create applications on top of it, applications that are completely decentralized, that can be completely decentralized, not necessarily, but you have that power. It can be automated and anyone can have access to them, because it's all decentralized on different nodes. And we'll see in a bit how does that look. So blockchains, when we think of them as in an architectural point of view, or not architectural necessarily, but just how we can understand it better on how they are distributed, you can think of them as computer networks. And each node is like the most basic element of this network. It usually is running on a computer. It can be a virtual computer, it can be a physical computer. It doesn't matter, as long as it's running the program that enables you to run like the proper blockchain software. It can be Bitcoin, Ethereum, any other. So blockchains are distributed like this. Each node is a computer, and each node holds an exact same copy of the historical information of the blockchain. So what is this historical information? You can see here, it's a database. And the database, the way that it's stored is instead of tables, as we can see on SQL or SQL databases. In our case, the way that blockchains store information is blocks chained. That's why it's a blockchain. Each block is chained to the previous block. We're going to see with a hash, with an identifier that lets you follow the exact trace of which blockchain comes after which. And any information, any data that is part of this blockchain, it's going to be stored in the block. So the data, for example, in the case of Bitcoin, which I'm showing again down here, it's all about transactions, right? So all of these transactions can only be, the data that is here is linked to the previous one. So it enables us to keep a track of how much, for example, Alice has been receiving and paying on each block. So we can keep a track of if Alice pays 50 first, then it receives 70. So now it has a plus 20, then it pays 60. it should probably have like a previous balance because we're going under for 60, and then it's on now 40 negative, and then Alice pays again 80. So that's a way that we can keep track of this information. This is very specific to Bitcoin, the transaction part, but we can keep on Ethereum any kind of data in these transactions, on these blocks. So we will see how this enables us to view Ethereum as a state machine, or any blockchain as a state machine, where we have information on the block with time n, and the n+1, we have still the information from the previous one with any modification, but it has to make sense. Like you cannot, and if you try to do like crazy stuff with this data, we will see how you can get caught with that. So it enables us a way to prove that our information, the data that is stored in each block, it follows the previous state in a proper manner. And since it's distributed, all of the nodes have to be have to agree, have to have a consensus on what the next state is going to be. So if we'll see in a bit what this means. So why is this important in a sense of why are we all here? So this is probably something that you've heard or read about before, this Web3 term, which comes from this idea that the Web1 is the first iteration of the internet in a way, or the first wave of apps or websites that we published. So the first ones were very static, were probably blogs, just static websites that came with information from, I don't know, a company, information about a specific hobby. You could take hours there learning and reading, but you couldn't actually modify it. It just had to be published every X amount of time. Then Web2 came with social media or social web, where users are starting to get a lot more of power creating content. Blogs is kind of this transition, like enabling anyone to create a blog and post on their own site. This was a new shift. So you can not only read now, you can also write, and it gravitated more and more towards the kind of applications that control right now the internet. Meta with Facebook, Instagram, which are places where you can write or publish whatever you want, pretty much. And however, it's fairly centralized. You have this danger that you don't own that data, you don't own those accounts. So we've seen it time and time again. Meta cancels accounts, Twitter bans people, Instagram takes away accounts from one person to sell it to a corporation. And this is possible because, hey, the content is all owned by the corporations. It's all centralized. So that's where Web3 comes in. So Web3, through this decentralization, this power that the blockchain gives us, you can not only read and write, but now you can also own. And it's this internet of ownership where we can own assets. The first shift was with Bitcoin, where you can own a digital asset. And now a lot of us probably have tokens, have NFTs, and even on some decentralized social media or social networks, we can also own our accounts, such as Farcaster. I own my account, and I'm the only one that can actually decide what to post or not. But of course, this is going to be a gradual shift, and we're going that way. It's all about the decentralization, owning your own information, owning your own assets, your identity, and providing a censorship-resistant alternative, so we can move from this centralized, controlled internet to a more centralized internet. It's very philosophical, this part, but it also enables anyone to create tokens. It enables anyone to create new economies, new solutions, without having to pass through a lot of regulations that are centralized, that keep the power on the people who already have the power, and governments and all of this. So that's what really excites a lot of us. In my personal, I can say I really like this approach. And we use a stablecoin here in Mexico that's completely open source. It's completely community governed. So this is the kind of solutions that we want to see you build. It's not going to be in 4 weeks probably, like a full stablecoin, but who knows? If you're interested in this, hit me up and I can help you set it up. So yeah. And how is all of this enabled? It's all through smart contracts. And before moving into a little bit of the more technical side of the blockchain, because we will see how blockchains work in a bit, I just want to dive a little bit into the whole idea of agreements. And it all comes back to this centralized part, because the world pretty much operates on agreements. There are social contracts, there are legal contracts, there are a lot of traditional contracts, and any interaction, social interaction, like we're social beings, everything involves agreements or contracts. If from small things like agreeing to wash the dishes on your house, or I will go to the gym, like a commitment with your friends, but also like on business, like purchasing goods, receiving services. All of these are all contracts or promises that we make between different entities. I promise to pay you, or I can pay you at the beginning, and you promise to give me, I don't know, apples, or you promise me to give me UX design service, whatever. And all of this is enabled or built upon trust, because you have a contract, like a legal contract. Well, you kind of trust that there's going to be a framework that's going to allow you to, in case of a dispute, resolve that dispute in a proper manner, instead of having to have to go through punches or whatever. So agreements is all about trust. So contracts, agreements, we all place our trust that the other party is going to be delivering. However, we've all been betrayed in a way of our trust by other parties. It can be from small things like, hey, somebody tells you that they're going to be at X place at Y time, and they don't get there on time, right? So that's like a breach of trust. Small one, maybe it's your friend, that he or she is always late, so you can let it slide. But what about the service that's actually like you depend on that for your business, and you don't get the proper level of agreement? Internet goes down. Hey, I'm paying for the internet, so you're supposed to deliver me internet, light, all of this. But there's always vulnerabilities and inefficiencies, and that's part of like what happened with Web2. There's this very famous account from Discovery. I think there was this person that was just like somebody who liked to travel and shared good content, and had the handle at Discovery. And one day to another, Instagram just took away that account, all of its followers, and hey, maybe the agreement was, the contract says that they can do that. Probably they do, but still, like, it's a breach of trust, and this happens with centralized services, yes, and other inefficiencies that can happen. So that's why all of this smart contract idea is moving us towards trust minimized system, because smart contracts are agreements that are code. So are a set of instructions deployed as code on a decentralized blockchain. So think of it as a vending machine. A vending machine has everything already. Kind of, it's a very fun smart contract to think of when you think about it, because it's a machine. It already has an operating system that's running code that has perfectly programmed how much is going to charge for each of the sales, or like for the products. So A1, maybe it's a Diet Coke, A2 is a regular Coke, A3 and all the top ones are beverages, and the bottom ones are food, and each of them has its specific price. It knows how to receive money, it knows how to calculate how much it needs to give you back, and it knows that if the payment is at least the same or over the cell that you pressed, then it's going to deliver you that product. All of this is kind of a smart contract. It has its code already deployed, and in this case, it's centralized because it's running on a physical machine that's on a physical place. But imagine if you could have a virtual kind of like Ready Player One system, where you can ask for I don't know, a sandwich, and it gets delivered on spot just because you have this virtual machine that can accept this order. That could be how you can think of Ethereum and smart contracts. They are immutable in the case of smart contracts on the Ethereum ecosystem, and most of the blockchains that have smart contract capabilities. That's part of the whole thing. Is once it is deployed, that code cannot be altered. There are ways to upgrade contracts, and we're gonna brush on top of them next week. But in essence, contracts cannot be changed. They are self-executing, like the virtual machine, like the vending machine that we discussed. It automatically enforces the terms when the conditions are met or not. Like if you don't pay enough, it's going to give you the product. It's going to be the same for smart contracts. The code enforces all of the conditions, and it's transparent because the code is always visible to all parties. It's since it's deployed on the blockchain, it's completely public. However, there are ways that we will also see on how we can explore this code and make sure that this code is already verified and is easily translatable to a more readable language, which instead of the way that it's actually stored on the blockchain, and we'll see that in a bit. So that's like the intro to the blockchain, and now we're going to be doing some on-chain action. We're going to be doing some exploration of how blockchain works. So the first one that I really want us to take a dive into is this idea of hashes. So we're moving to the cryptography side right now. So we talked about networks, we talked about decentralized, about blocks, about data, and all of this is powered by cryptography. That's why they're called cryptocurrencies. And we'll see in a bit how it all ties together. So hashes is the digital fingerprints that we can have available when applying cryptography. So what hashes do is they take any input data. It can be simple text such as hello world. It can be a huge file. It can be transaction data. It can be structured data. And it's like a function. So you send in an input and it produces an output. So it produces a unique fixed length string of characters, which is called a hash. So if I put hello world into the hash function, the output is going to be a fixed length string of characters that can only be generated by the same input. So that's where the deterministic part comes in. So if I enter hello world with a 0 instead of an O in the world part, and also on the hello, each small change is going to produce a completely different hash, a completely different output. And these outputs are always going to, if I enter with a very specific hello world with just 1 0 in the hello, it's going to produce the same all the time. If I do the hello world with both O's as a 0, then it will also do the same, create the same deterministic, which will be different than the first. And we'll see that in an example right now. And the avalanche effect that happens is that just one small change in the input is going to give you a completely different hash. So that's important to know. Any change is going to be very apparent that it's not the same hash, and you can only do it one way. So you have and the input can only be hashed and output, but the hash cannot be turned back into an input. It is possible, but you will need to, it's just not feasible to use that time. And it's going to take probably millions of years or even more. So I'm going to open this demo, which is a very good resource to get understanding. This is built by Anders Brown Worth. It has some videos here, but this is what the hashing function is. And we're going to be using the SHA-256 hash function, which is different than the one that Ethereum virtual machine uses, but it's a similar. I believe it's from the same family. Don't get too hung up on that. It's just a hashing function. So what's going to happen here? You can see there's a hash here. It's going to be the output. So this is what I meant by hello world. So this is the final product, the hash. So what if we put like a huge and lorem ipsum is just like a huge text that's been used like for a while. And if I enter all of this information, it's still going to give me just one hash with a fixed length. So this is the SHA or SHA-256 hash function. And it's always going to give us, for this same input, it's always going to give us the same output. So you see, it ends with DAD, and it starts with 22. So it doesn't matter how many times I paste it, it's always going to start with 22 and end with DAD or that. If I enter even just one new line, you see that the hashing function changes. So for the computer, for the function, this new line enters a new variable, which is all of these strings. And every time that I enter new data, it's going to change. So going back to our hello world, this one ends with CD E9. And if I change just this to 0, it's a completely different hash. Same if I change this one to 0, a completely different hash. So this is what a hash function is. It's just a function that takes in an input of data, and the output is a hash of fixed length, a string, basically. So this is the first thing about hashes. Then the next one is going to be blocks. So blocks are containers of data. Like I said, it's the way that the blockchains store data. And blocks usually have these, and we'll see in a bit, these variables. So each block has a block number that's kind of the identifier of which block goes, it's a current block, or if you want to know the data of a specific block, that's the identifier that you would use. They usually come with a timestamp just to keep it like part of the metadata of the block. The data, which is a collection of validated transactions or any other information, and we'll see what that means in a bit. The nonce is just for each block, when it comes to proof of work, it's a number that needs to be found. You have to apply a mathematical function to get to that number, and it usually has like a very specific requirements. I wouldn't go dive. It's just like, just think of it as part of the problem that needs to be solved, and a valid nonce is the only way that a block is actually able to be minted or generated. And of course, and the other one that's very important is the hash of the previous block. So remember the hash function that we saw just right now. We have a very specific use of it. So each block, all of this information, the block number, timestamp, data, and the nonce, is going to be entered into a hashing function. It's going to generate us the hash of that previous block, and we will use that hash to chain our new block with the latest one. And that way we can create the chain of blocks. So a block bundles data, such as transaction or the state of the blockchain, with some metadata, the block number, timestamp, and nonce, and hash of the previous block, to form a chain.
I think now's a good chance to interrupt you here for a second, Mel. Jessica wants to know, and I think it's a great question, right? So is the hash the same, the string that outputs, is the hash the actual same for the same input for everyone who's using the same hashing system? So if you and I both go here to this demo and we both type in always, you and I both get the same hashing output?
Yes, it should be, at least on these systems. So that's a way to keep track of this, and we'll see in a bit, because it's important for everyone to validate that the hash, and because we will be sharing this here, this block information, we all will have a copy of this chain of blocks. So if somebody, and we'll see how does that look, if somebody alters one of these blocks with malicious data, with different data, trying to get advantage of the availability of the information and move it in their favor, others will be able to see that, hey, since they are not replicating the data, replicating the hash with the same data, they are using different data. That means that they are malicious and they are not using the same data as everyone else.
They're lying about what's in there.
Exactly.
So it's almost like the ability to peer review. And so she has a follow-up question on that too, is, so do most people use the same hashing system? Or at least like in the context of Ethereum, are all the hashes produced using the same cipher, essentially?
Yes, in the case of Ethereum, I believe it's KCAC 256. It's a different cryptographic function. But yeah, like, and all of this is usually run by the validator nodes and the nodes that are part of the blockchain. So it comes with the operating system, and that's what keeps it secure. Like the software and the different clients, all of them have this information and these functions designed like that. You have to download the software, the operating system, and run it, and they're all designed to be compatible with the proper hashing functions and everything else that is needed.
And then just one more follow up on that too. So if you and I both type in the same input and get the same hash, and I see your hash and know that it matches my hash, then I know what your underlying input is too, correct?
If you have the both, yes. I mean, you should have the same data. So yeah, it's I mean that you have to have that input. That's like a way of you kind of like knowing that you both hold the same input, but the other way around, like from the hash, derive the input. Only if you know that input, you will know that, hey, yeah, he has or she has this information encrypted or hashed into this hash. But that's because you know the output already. Like you will need this both of the data to actually know that you both have that. I don't know if I'm like.
No, that makes perfect sense. Yeah, that makes perfect sense. And that's, I think Jessica gets it as well, is it's highly unlikely that I would know what your input is, so that way I could have, both sides of the cipher, but she's make sure she's understanding correctly. Yeah, if I type something in and get a hash and I see your hash and it's the same hash as my hash, then we obviously input the same exact thing.
Exactly. So this is what continuing with the lesson. This is where the chaining blocks and immutability. Wow, that was hard. So a blockchain is, like we said, a sequence of blocks or chain of blocks, and as we've been saying, each block has a connection to the previous block via the hash of the previous block. So this gives us the immutability. So say that we have a chain of blocks and somebody wants to alter some of the data of a block 3 blocks before, let's say block n minus 5, even 5 blocks before, then if you change this information, the hash of this, remember, we're going to apply to this block n minus 5. This is the example that I'm giving, but it says -1 here. So whenever we apply the hashing function to this block information, now it's going to be changing. The hash is not going to match. So this is going to invalidate the previous hash stored in block n, as it says here, or n minus 4 in our case. And since that's going to change, all of the other blocks that follow are going to be invalid. How does that look? And we're going to use, again, I think it was also on this one. Let me see. Here. Yes. So this is how block looks. So if I mine this, it gives us this hash. But if we enter any other information here, it already changes what the block was, right? This is what it had before. This is a valid block, but when we mine it, it already gives us this hash. But if we modify and we entered some data here, we will need to mine it again. And now it's valid because it's generated the hash with the information that we've been providing to it. If we enter a new block, it still will need a new hash because it's changing the information. So any change here is going to give us a new block. And the nonce is the one that gets calculated. I don't want to get to that too deep into this because it's mostly used for proof of work systems, and on the EVM ecosystem has all moved towards proof of stake. So this is already like done by the validators. Don't worry about it. But what we really want to start looking is, we click on the blockchain part, is here we have a set of blocks, and we see that all of them have the previous hash. Let's say this one, and is 000B9015, which is linked to the previous block over here. We can see that it starts with the same, and it happens for all of them. So what happens? This is a blockchain. There is occurring right now, and it's all green. However, if somebody wants to change some information here, like say, I'm just going to put like hola, and we switch this one's going to be valid now, but all of the blocks that follow, they are not linked with this hash because it's a different hash. So this hash that we have here, it's trying to link it. It's the same here, but it's not valid. Like it calculates what it should be, the data, but it doesn't correspond with the data that it has here on the hash. So we need to mine this again, and we have to do it for all of the following blocks. Now, this is good. I mean, you can do this if you run a centralized blockchain with just one copy of the blocks. But what happens, we have a distributed block, and we have different peers who are running the same software, are running the same copy of the same blockchain. And I do the same in this, let's say on peer B. I change this and I start to mine blocks again. And they're gonna say, hey, I have a valid blockchain until block 5, but I have this information. So the nonce is different from both of the A's and C's blockchain. So there's something wrong. Like there's no other way around. Even the previous hash, you can see that it doesn't correspond to the previous one, and the new hash also doesn't correspond to the new one. So this way, this peer A and peer C could see that peer B is modifying the data. Of course, now this replicated, not sure how many nodes there are right now, but it's a huge amount. Let's see how many Ethereum nodes are there. Over 9,000 nodes. So it's going to be very hard to coordinate all of these 9,000 nodes to try to change data. So that's part of it. And when we start diving more into how does it look on a transaction kind of like approach, where there's data that we have some information of transactions, and peer B says that, hey, no, maybe I'm Hicks. Sorry, maybe I'm Newt, and I want to earn more money here. I'm gonna change to 100. So I'm changing it, but now that's I'm already flagging that, hey, I'm moving the data here. So all of the other peers can see that this block is not actually following the latest block. So there are several things that need to happen for this kind of hack, if it even can be called a hack. But it's just, this has never happened, and it's very unlikely that it will happen again. It will happen because you will need to control over 50% of the network, and that's a 51% attack. This has never happened. So why? Because you need a lot of amount in the case of proof of work, you need a lot of electricity, computational power. In the case of proof of stake, you will need a large stake, and it gets slashed if somebody sees that you're doing bad blocks and all of this. So that's like the overall view of the blocks and the immutability. And now we will move toward transactions. And I'm gonna pause a little bit here on the examples because I want to show. Let's see. Maybe I need to remove this for a bit because we will be installing our wallet for and we will be using Syrian for this one. This is our like we will do our first transactions right now, and for this you need to download the extension for your web browser. I'm using Chrome right now, so all of this is going to be something that we're going to be doing it very simply right now. We're going to be creating a new wallet because we will be using cryptography, the cryptography part, on how to understand what is happening here. So you probably already have a wallet. So we're going to create a new one. It's going to put a basic password here. Maybe not as basic. And let's see if I put it right. There we go. and we're creating a wallet. So wallets are these softwares that allow us to handle a lot of cryptographic information for us, cryptographic functions, and several things. And one of them is these things that we saw here that are the recovery phrase, which is a very powerful thing that you should never share, please, because this is part of the cryptography that allows us to control this in a decentralized manner. So usually when we handle assets, we can keep them, of course, in our wallets, like our physical wallets. I have one here. It has some money, some cash, and yeah, I can handle some amounts of money in my wallet, no problem. But what if that assets start to become a little bit large, and I get mugged, or I lose my wallet, and I will never be able to get back that money, right? So that's when we start looking for solutions such as banks or safes that can hold the money for us. But here's where the centralization comes. So with banks, we have to trust in this third party that they will keep the money for us. And this is something that has happened before. Sometimes it loses money, right? I don't know if you've seen the South Park episode where, and it's gone. Yeah, it has happened at that a lot of times. Not only banks, other services, exchanges happened a couple of years ago. So that's why it's important for the blockchain or for the on-chain ecosystem, this part of the wallets that you are able to control them. And there are like different types of solutions that allow you to control them. One of them is this wallet software that allow you to handle the private keys, no, so you can sign transactions. And others are smart accounts or smart wallets. There's been a lot of advances on the EIPs for smart account and treating smart contracts as accounts that can be handled as externally owned accounts. We'll see that in the next session. But the important part is for you to be able to interact with the blockchain, with smart contracts, send tokens, receive tokens, and all of this, you will need to create an account. That's the simplest way that you can think of it. So the same way that you need an account to interact with email, for example. So with email, really what you need, other than an account on a service, I don't know, Gmail, Outlook, or any of these Proton Mail, any other of these email services, actually what you really need is an address. That's what they give you as part of their service, an address, an email address that has that for the system, for the protocol that email uses, which is SMTP, Simple Mail Transfer Protocol. I believe that's the acronym. This one gives you the ability to receive emails on this address and to send emails through the protocol on behalf of that address. So usually what these services do is they give you this email address and you can control it with a password, right? So we can think of accounts on Ethereum, on blockchains, specifically for the Ethereum virtual machine, as these accounts that are handled in two ways. One of them is the public key, which is similar to the email address that gives you, this visible information that allows anyone to know that this is your public identifier. So they can send you emails, or in this case, assets to this address, and the private key. And it changes a little bit. It's not actually, the public key is not necessarily the address. It's used to derive the address. But the private key is the important part. And this is like your password. So if you lose your private key, you lose your password to your email account, somebody else finds it, they can control your email. Same thing with the private key. So this is all of this is used. So the blockchain knows that a transaction or transactions are actually sent by the claimed owner, because we've been doing like this kind of this is not great, but Alice and Charlie holding this transaction information here. However, if it wasn't, we didn't have this layer of authentication in short, which is what the private key security is. anyone could access any account and move accounts, move assets on behalf of that account. Transfer out USDC, transfer out ETH, transfer out POL, and nobody could stop you, right? So that's where these digital signatures come in. So the private key is enables you or anyone with the software that handles private keys to create digital signatures that allow the blockchain to understand, hey, the account that is owned by Mel is requesting that they send out X amount of USDC to Kale for the beers that they had at I don't know, Denver, right? So I would need to sign, as when I do with cards, you need to present that card, and that card has a digital signature as well. That is usually a wavelength with the NFC chip, or the very same chip that comes in with the card. Well, it's the same, but now instead of doing it physically, we do it with numbers, with huge numbers, and that's where the cryptography part comes in, and that's where we start delegating these kind of operations to a party that helps us with this, which are wallets. So wallets help us handle our private key securely. Do know that you cannot just trust any wallet. There are several. That are more well known than others. There's Syrian, which is the one that we are using here. There's MetaMask, there's Coinbase, there's Rabbit Wallet. There's several that are very useful. Rainbow Wallet also, but there are a lot. Just make sure that somebody else uses it. Ask around, see who likes the most. Maybe you can try a couple of them, but most of them are secure, at least, especially if somebody's recommending it. But always be careful when handling this part, because this is where a lot of people have some troubles. So what's this private key and public key? So let's see. I don't have a referral code. Okay. Let's see. So if I back up this, and here's where we have one of the first methods to generate these private keys is with a recovery phrase. The recovery phrase is the only way to access your accounts and assets. So this is like your master password. Any address, this is any address that is generated with this recovery phrase. If somebody else gets control of this phrase, you're going to be having problems. Let's see if I remember this. And
yeah, this is probably a good. Yeah, I'll let you think for a second. It's a long one, Mel.
Yeah, probably messed it up. That's fine.
That's a good time to probably answer this question here from Shruti. So are wallets meant for specific chains, or are they independent of chains and kind of allow transactions on any chain? How is that managed?
It depends on the wallet software. Ideally, yes. Like Syrian, for example, this is an account that can be used for any other Ethereum virtual machine compatible blockchain. But just make sure that you can trust it. There are some wallets that are more limited in this sense. So, if you need to check it, just always ask for a test transaction. That's a good practice. In my experience, Syrian does this well. MetaMask does it well. Hardware wallets also do it well, but it depends on each wallet. So don't take it for granted. Yeah.
And probably the more fundamental difference, like you're mentioning, is whether it's like Ethereum aligned, if it's EVM compatible versus an alternate ecosystem like Polkadot or Cosmos or something totally different. The Arweave wallet is not the same as an EVM wallet.
Precisely. So yeah, I'm gonna move very quickly to some demos of this private key and public key generation. So a private key is usually, I don't remember how long it is, like maybe 64 characters. So we're generating random keys, and mathematically speaking, the chance of someone else getting the same exact private key as you, it's I think it's more possible that lightning strikes twice in you than this, something like that. So this is just like a generation of a private key and a public key. And then with both of these, we can sign transactions. So for example, hello Dabl. Here I'm applying a signature function. So I'm entering the data. It's similar to a hashing function where we enter a message and we use our private key to generate a hash. I mean, this is not specifically a hash in this sense. It's similar to a hash, but this one is specifically a signature. So if I change the private key here, everything changes. So it's the same. It's just a very simple way to show this, and generate a random one now. And what we can do now is verify, and we can see that with the signature and the public key, we can verify that this message was signed by this public key, which is, and once again, linked here with the 0456. Here, it's linked to our private key. So that's the way that we can verify that a transaction is actually sent by the private key. Now, of course, we are not going to be handling these private keys on our heads. Like, I mean, you could learn it, and that's probably the safest or one of the safest methods, but I would recommend it. Just use our wallet so you can actually more easily handle this part. So this is what we said, private key and public key. I'm gonna jump a little bit faster here. So this is a little bit more of what it looks like. So the private key is this long number, and using cryptographic functions, we can derive the public key and also generate digital signatures, which allows us to handle the accounts that are under these addresses. The public key allows us to derive a public address, which is the one that we usually see when we ask, hey, where do I send you some money to pay you for the tacos that we had last time? Okay, so send it to this public address. This address is part of this private public keys pair derivation, so it's all linked. And yeah, again, we cannot highlight how important it is to keep your private keys and your secret phrases safe. If you lose them, you lose everything. So right now you can see I'm not revealing my private key or my secret phrase here, which is also because I kind of put like a random password. It's okay, I'm not gonna be sending money here, but it just shows you how easy it is to create wallets and receive assets in case that you want to show somebody. And yeah, it's important for you to know that if you lose a private key, you're probably gonna lose everything that you have in that address. So that's where wallets come in, because they handle seed phrases and private keys for us. This is a little bit of theory that you can read on later. And now we're going to move to our first smart contract. Okay, so first I'm going to show very quickly how to, let's see, want to add, MetaMask mode now. So we have some chains here, and we're going to show on Polygon. You should be able to see testnet. Let's see, where can we enter them? Here. So for the whole, for the demo that we're gonna do now, right now, deploying a very basic smart contract, and you know what we'll be doing during the DevCamp, we will be using Polygon Amoy. It's up here. Let's see, it works. Well, the simplest way to do it is to go to chainlist.org, and we're going to search for Polygon testnet. Here we go. We just connect our wallet, and I want to add this one.
And maybe just one quick differentiation too for those who are maybe unfamiliar or haven't played on test nets yet. What's the main difference here between a test net and a main net?
Oh, thanks. So yeah, testnet is basically, mainnet is where the money is, like it's the real world. So any asset that's on a mainnet is kind of, for example, Ethereum has its own mainnet, Polygon proof of stake has its own mainnet. So this is the chains that are production environments, right? So if you've ever done like some building, developing, or whatever, you usually have like an environment that's actual live environment where people can access the website or a program that's actually using real data. And the test environments, they're using mock data, seed data, data that is not real, that any change or any loss of this data doesn't hurt, doesn't matter in a sense. So that's similar. That similar approach happens when it comes to blockchains. So we have environments. Each blockchain usually has its own mainnet and some testnets. Testnets allows us as builders, as developers, to try out new things, try out smart contracts on a production-like environment with a distributed network that has latency, that has assets, has users even, and has some usage that can actually show us some experience of how the production deployment would be, but just without us risking asset loss, basically. I don't know if that worked. So here we have Amoy. Okay, can save it, and now we should be able to see it. Yeah, we're connected to Amoy. Perfect. So what I'm going to do very quickly is I'm going to send me some testnet tokens on Amoy. Okay, wallet. No. Here we go.
I sure you was thinking exactly what I was maybe about to make a comment on. Is there any good strategy for faucet? Been struggling with getting some ETH on testnet. Faucets are limited. How are you seeding this today?
Yeah, for right now, I'm gonna do very basic. I'm gonna send some testnet tokens that I have here. I'm gonna struggle with it right now because there are some that I like. Alchemy is usually good. I usually have good faucet Polygon. So this is one that I like to use. Maybe need to. I think you were able to log in before. We can just test it, right? So we copy this. Okay, I need to have some money here on Paul. So yeah, maybe I can send me some Paul right away. And I'm gonna scan this. And it asks for a very small amount. Okay, transferring. So it should show in a bit. It works. It's the only ones that are coming. Okay. Okay, perfect. Now I have Amoy. That's because I sent you some Paul on mainnet.
And every faucet provider can have their own rules or their own screening or their own requirements to be able to distribute those test faucet funds. So you got to kind of do a little homework. I use the ETH Global faucets pretty regularly as well.
Those are good too, yeah. So yeah, I'm just gonna stay here. So right now I should have some poll tokens on Amoy. We're fetching for Amoy. Okay, don't worry about it. And so now that I wanted to show very quickly. Now we have some Amoy tokens here. It's not showing my balance. Okay, let's move to. We will be using the Remix IDE for this this part because we will be showing a very simple smart contract here. And just want to see if now we have the information. No, it's gonna show you that we actually have it. Polygon scan. So you see, I have 0.1 poll, and I can send. Let's see, I can generate a new wallet very easily here. Creating wallet. I'm part of this group. Yeah, I don't remember this one in that case. No, it wasn't the blunder. Okay, I cannot do this.
That's pretty funny to me, Mel.
Yeah. I mean, I put a new password, so I must have put like something bad there. Anyways, yeah, I wanted to show. Well, we can see that the poll is here on my address, but so yeah, usually EVMs or like the Ethereum virtual machine, and the way that smart contracts are deployed or the code is actually run on this Ethereum virtual machine is on this bytecode. So we as developers don't really know how to do all of this. We don't know how to read this. It's all data. It's almost binary. So machines can definitely read it, but we cannot. So for this is why we create the Solidity language was created. It's the language for Ethereum devs, the most widely adopted. There are a couple more, Viper, FE. I'm not sure if it's still going. Solidity is pretty much the standard. It has a similar syntax to JavaScript or C++. It's an object-oriented language, object-oriented programming language. It feels a lot like JavaScript at times, but it has a bit of a more strict typing and just in general syntax. And it's Turing complete, which means that you can code pretty much anything on it. And one important thing to keep in mind is these are Solidity is used to build smart contracts, and since the smart contracts are deployed on this universal computer or world computer that anyone has access to, there are a couple of things that we need to battle with, which is gas. It's like a way to pay for the computational power, and it also helps us diminish the amount of spam that can be done to the chain. So you probably have heard people talk about, gas price is very high, transaction cost is very high, especially on Ethereum mainnet. That used to happen a lot, especially a couple of years ago. Now with all the scaling solutions that are available, and Ethereum has done a lot of great work to lower these costs, but there's still a cost associated. So we need to keep in mind, and that's why we went through the hassle of, not the hassle, but just like getting some testnet tokens so we can create transactions, we can deploy contracts, and we can pretty much participate on the chain. So that we're going to be using Solidity to create our smart contracts. And we need it because the Ethereum virtual machine doesn't understand Solidity. Solidity is it's a programming language. It's an abstraction of the information, the code, the bytecode, that allows us to use a more human-like language. It's still not fully human, but it has some words that help us understand better what we are trying to do, and that's what the coders do. And we use Solidity to create our smart contracts, and it gets compiled into bytecode, and also something that is used as a footprint to know what this smart contract is on a world that is not bytecode, which is called the ABI. We'll see in a bit. And the bytecode is the code that the EVM executes. So we'll see how we get compiled and we create these artifacts, the bytecode and the ABI, which is a way to translate what's happening on the bytecode side. These crazy 0 and hexadecimal numbers that we have no idea what does it mean. Well, for us, we use Solidity to create the smart contracts, but for our applications, we provide them with this footprint that is this blueprint that is the ABI, the application binary interface, which is similar to an API. REST APIs have a very specific way that you should call them to get the data that you want. It's very similar. The idea for ABIs, you provide a blueprint of what are the functions and the variables that your smart contract has, and translates them to the application so they can use them and they can interact with them. And we will be using ABIs during our DevCamp to interact with our smart contracts. This is a quick translation of how does the ABI smart contract look as a Solidity contract, and how does it look on the ABI. On the left is the Solidity code, and on the right is the JSON object that is, or the JSON file that is generated as an ABI. And yeah, this is a small diagram that how does it look. So we're going to do this right now. We're going to create some Solidity code. This is going to be the code source. We're going to compile it, deploy it. Once we compile it, we generate the bytecode and the ABI. Then once we have this compilation, we will deploy it, and it gets deployed into the EVM or to the virtual machine. In this case, we will be using Polygon Amoy. And then it's stored as bits and bytes that the virtual machine can now pretty much execute as code. And for users, for applications, they will need to go through the ABI. You need a front end or any other TypeScript or any other language application. Usually JavaScript is what I use the most. And other apps can also use it to get information from the responses from the contracts. So this is a small show of how we're gonna use when we go to the front end. If you're a front end developer, this looks a little bit more of like something that you probably use. This is TypeScript in this case, or JavaScript, very similar, because it's just a call of a function. And this is how we can start integrating contracts. But first, we need to create a contract, right? So we will go to our Remix IDE, and we're on the right one. And okay, we already have one here. That's interesting. We have an ERC20 contract, but I'm going to remove this just because we want to go to the very easy way right now. So we're going to create our first smart contract, and let's create a new file. Example contract.sol. And for Solidity contracts, we usually need to start with with our pragma Solidity, and we need to define which is the compiler version that we will be using. So this is we're getting to the technical part. Solidity, it's also a program that is constantly evolving, as is the virtual machines that run on top of the blockchains. Depends on which one you use. So you have to keep in mind these versions whenever you're using you're creating smart contracts. It usually isn't a big deal unless you're doing stuff that I think I'm going to put what was it? This one. This. So for example, I'm just put like a random version, but it says here, okay, so the compiler is currently using 0.8.30. Let's switch to that one. Let's see. Okay. What's the program thing? I'm doing it right. Parser, certified different compiler version. It's gonna ask keys. Exactly what I have. Maybe I just need to put the. We also need to enter facility and compiler version. Let's see. Sample construct. How am I getting this now? Okay. I think, I just need to put the. So 0.8.10. This create a new one here. Contrast. Okay. Yeah, seems like it's missing this syntax. Anyways, so usually smart contracts we have these two starting like opening lines. So the first one is the license. So common one is MIT. This one is also good. This is just for like allowing anyone to pretty much use your code in any way. The GPL is a little bit more strict, but nothing important right now. The Solidity version, Pragma Solidity directive, is just to tell which compiler version we want to use. So yeah, right now it's entering correctly. And then we have some definitions. This is just like good practice. You should, I mean, if you can do it like this. Right now we're going to focus on the code, just the code. So I'm going to remove a lot of stuff here. And this is a basic storage contract that has been created by the Remix team. And what we need to know when we're working with Solidity, and I know we're almost close to the time, we're just gonna go very quickly. Solidity, we have these keywords such as pragma. Solidity is also a reserved word. Contract is a reserved word. Usually the ones that you can see in a different color on your IDEs, and here in Remix we can see them on blue. These are words that are reserved that indicate what type of object you're declaring or instantiating. So here we're declaring a storage variable that is a contract. So we're telling Solidity, hey, I want you to create a contract that is going to be called storage. You can change this to anything you want. It can be my storage. It can be storage contract. This is completely variable. And then we have to open curly braces as such. And when we go through this, what we're saying is, hey, I'm going to create a new contract that's going to be called like this. And it's going to contain all of this logic inside of it. The first things that we include inside a contract are usually the state variables. These are going to be variables that are going to hold for us information that is going to be relevant. This is going to be stored forever on this smart contract. And it can be updated, yes, but we'll see in a bit how. So for example, in this case, this contract called storage contract, or we change the name to storage contract, is creating a uint256. This is an unsigned integer. So what this means, it's a very large number. Where it's uint256 range. It's insane, like 0 to 2 to the power of 256 minus 1. It's a huge number, like seriously. So you can store a very large number here, in other words. Maybe we can change the name, but this is, they just named the variable number, but we're going to call it stored number. So this contract, what it allows is store any number inside this variable. We can think of this as a box. We're declaring a box where we can store an unsigned integer. And as you can see, since I changed this variable from number to stored number, we have some errors here. So this is our first variable that we created, stored number, and it's a uint to 56. Maybe we want to store something different, maybe a string. We can put stored string. And these would have a different type. So for this one, we could only store strings like this: hello world, hey there, Kenobi. It was hello there, right? Hello there. And here we're going to have just 1, 5, huge number, whatever. There are other variables that we can store. Bool is is Kenobi cool. And the bool, it allows us to store true or false. True or false. And we can like go through different types of variables. We will be using more and more as we progress. A very fun one is this mapping one, but I don't want to get with heavy with the code right now. So I'm just showing that you can create different variables. And for this, these variables, whenever they are like created, they are not holding any information right now. So they will be, in a bit we'll see 0, but don't worry about it right now. So these are the variables that we create for our contract. They're going to store some data that are going to be accessible till the end of world if we deploy this information, at least till the blockchain stops running. And then after creating our variables, we will create functions. Functions allow us to execute the logic that we want into our smart contract. So like I said before, previously, the variable that was created by the contract, the default contract, was called number, and we changed it to stored number. So as you can see, we had a couple of functions that allowed us to store the number or retrieve the number. So when it was named number, what the function did was it was able to receive a new number, which is this. If we think of it, it's a reserved word for function declaration, which is function. Then we have function name. Our name store. This is the way that we're going to invoke this function. We're going to have to, as we are assigning the word or the string store to this function, and whenever we want to execute it, we will be calling it. And or on the front end or any other contract wants to interact with this smart contract, we need to call this store function. Then we have the params, function params or arguments. Is data that is passed along to the function. So this data, num, is going to be available on our function. Then we have function modifiers, which we have a couple. The most common ones, I believe, is visibility modifiers, which is public, private, internal, and external. And we'll see a little bit more when we need to use this. They're usually just to indicate which entities are able to call this function, at least the modifiers. It doesn't mean that it's like, if it's private, it doesn't mean that it's not visible. It just means that the only entity that can call this smart contract function, if you put this private, would be only this very specific contract. If it was public, anyone can call it, which is the idea of this. If it's internal, it means that only this smart contract, and if there's any other contract that uses this as a standard, like ERC20 tokens, I don't want to get too deep into this, but it allows any contract, either this or any other class that inherits from this contract, to call these functions. And external, it means that only external entities can call this function. This is this is gonna be, don't worry too much about it. When it comes up, we will dive deeper into this. We will see why they are called like this, and you will find situations where you're gonna need one or another, and there are efficiencies that you can, make ways that you can make more efficient if you only allow private or internal, or it's just more of a, also can be standard, just better practices. So I'm gonna keep it until that, and then we have our proper logic. So as I said, we have the keyword reserved for the function declaration, the variable, or rather the name that we assign to our function, which is custom. The arguments, this is also custom. Here we want to pass along a new number. A good practice is to use this kind of naming system, where it indicates that it's a variable that's going to be used inside this function only. So of course, it's just a matter, as long as you keep it consistent, just and readable, that's okay. But it's a nice to have. And the arguments and the visibility modifier. And then we have our logic. And our logic is only doing this. It's under our number variable, which is declared here on top. We're going to change to this new number that we're receiving. And to make it more clear, that's why I had changed previously the variable, because I want to show that we can use now, okay, so the stored number is the one that's going to be affected by this new number, and you can put new number. So this is a little bit more explicit on what it's doing. So here we are assigning the new number that is passed along on the function to our declared variable. So anytime that the store function is used, our stored number is going to be holding that number until somebody else comes and changes that number, okay? And how do we get that number? We use a retrieve function. It's very similar. So we have declaration for our function keyword, the name of our function. This one doesn't get any specific argument because we don't need it. It's a public function. It's a view function, which means it doesn't execute any logic. It just returns a very specific, it's like it accepts a request and it shows it to you. So that's what's the view function. What the view function is. There are another that are, I don't remember how is it called, but it's like I forgot that. So we have view. I think the other one was pure function, and it's more of their end result. The pure function can maybe just execute a calculation, and that's it. And it's not necessarily, it means that it's changing any logic of the contract. In this case, it is not changing any logic, but it's also not doing anything specific. So it's just a view function. And since we want to retrieve the stored number, we will need to change to our to the function that we actually, to the variable name that we actually are using, which is store number. So we compile it. It's compiling correctly, perfect. And when we compile it, we can see that we have some artifacts now. What did I name this smart contract? Give me a second. So the file name is storage, but the storage, the contract is actually called like this. So another thing that's important is try to keep always your smart contracts, the file name. Right, let me see. Storage contract. So the file name with the same name as the contract that you're like declaring on the file. And it's compiled, and we can see that we have the storage contract JSON. This is here we have the bytecode, and should have also our ABI over here. So this is all generated once we compile it. Like we saw before, we generate the bytecode and we generate the ABI. So we want to show that we have this generated. And once we have it ready, we can deploy. So the easiest way to do it is do it on this local net. Like it's a good simple, easy first step to take. And when we publish it, we're gonna see that it's been published here down. So right now, what we can do is access these two functions. I can put 23 as a store number. And maybe I should have shown you that the previous call. So right now we see that we have the 23, but by default, any variable, whenever it's declared first, they will have the 0 value. For numbers, for strings, it will be an empty string. For booleans, it will be false. So anything that has 0, how it will represent it on that type, that's how that's like the default value. By default, everything is 0 or false or null. Not null, but it's like a falsy value. Yeah. Okay. So that's a basic smart contract. We're going to create a new variable, which is going to be called function store string. A new function, and you have to declare it a little bit different because the way that the virtual machine works, this new string that we will be sending as a function argument, we want to modify the store string. So right now, let's see if we created, if we created a function called retrieve string, which is similar to this. Just have to put a different name, of course, because if not, we will have repetition, and that's not good. And we will be returning a string, and we have to return here a string. Yeah, I have to put this, I think. Okay. String memory, and so if we want to access this retrieve string, we also need to store string. So that's what we want to do, right? We want to be able to modify this store string because right now the value should be an empty string, but we want to maybe enter hello world. So now the way that it works, similar to what we did before, it was function, the function name, and now this new memory thing that appears here happens because strings are technically, the way we know them is, like this sentence or pair of words or whatever. But on code level or for the virtual machine, it treats them as an array, which is another type of string, say store string array. So this would be similar to store string in a sense, because strings are treated as arrays on a programming world. Like most of the languages treat them as arrays. So in order to avoid like this, not to avoid, but since this is stored as an array, it's a different type of what's the name? I'm skipping on. It's a different type of variable. Like literally, it's a different type. So we're storing. We're not storing primitive data types. That's what I meant. So we have these data types. This is what we've been doing. uint256, bool, but string is a different type of data type. It's not a primitive in some languages. So instead, a primitive one would be just a character, which could be H, could be the E, the the O, just a very specific character. But this is not how we use them as solidity. So just it's good to know, but it's not critical. The critical part is for you to understand, since strings are a different data type than what we are used to sending, we need to instruct Solidity how we are going to handle this array, this new type, or different type that is not a primitive type. So that's where the memory keyword comes in. Can be memory, can be called data. It depends on what is the need of your function. In our case, we're just gonna leave it as memory because we will be using that value to assign it to our existing string. So it was a lot of things just to say that for strings, we need to pass the arguments with this memory keyword, as well as here when we returned it, we need to specify that we will be returning a string as memory. So here, once we do that, we should be able to do stored string equals new string. Public. There we go. And we have the retrieve string now. So now, since we made some changes on our smart contract, we need to deploy it again. Okay, so we compile it and we want to deploy this contract again. So we deploy it here. And now we should have this new deployment over here. And if we expand here, we can see that the deployments are being done on a local network. Like I said, you can see it when we are here on this environment, or here it says entorno, but it means environment. We see that we have different environments that we can use. And after doing this, we'll do a very quick one on Polygon Amoy. So just to finish this example of our basic smart contract, if I retrieve this string, like I said, we should receive an empty string. Why? Because all of our variables, whenever they are initialized, they start with the default value, which is 0 or false or an empty string. We could do a constructor function, which we will do in a bit. I think we have a little bit more time. And yeah, so we have this empty string. Now we can store a new string. Is stored with typos. We click store string, and then we retrieve it. We see that we have the new version. Perfect. So now we're going to do something different very quick. There's a constructor function that allows us to initialize some of these values. For example, we are doing here store number. We're initializing with this one. Just to anyone, store string. And we can also pass arguments to this constructor function. This constructor function is going to run once and only once, which is when we deploy the smart contract. So here we also need to indicate for the source string, for example, we're going to do string memory as well. Initial string. Initial. I'm going to save it. And now we're going to deploy it as well. It's already compiled. And we're going to deploy it to a different environment this time. So let's see if we can. So connected. How can I connect my wallet? This is not it. Let's see. I should have MetaMask here. Do we need like a MetaMask like experience? No, it's so. Next. Okay, there we go. So I entered the wallet connect. Can detect network. Okay. Now we're going to switch to Amoy. Okay. Oh, yes. To support Amoy. Let's do it on Polygon Minute for a bit. I'll connect. Browser wallet. What? Okay. I need to activate this. So now that we have it here, perfect. All right, we should be good to go. This is a chain ID for Polygon Amoy. Now it's compiling our storage contract since we just changed our. Okay, it's compiled correctly. And now we're on our Polygon Amoy testnet. I'm going to use our smart contract. And as you can see, now it's not allowing me to just publish it because we created a constructor function that is expecting an initial string. And we can see it here that it's asking us, what is this initial string? Hello, Dabl Club. Can publish it. It's going to ask me now to send a transaction. Okay. We see that the contract has been published and it's now here. And if I retrieve the string, we will see hello Dabl Club, which is exactly what we put here. And yeah, that's like the starting point for our smart contract adventures. So yeah,
that's huge.
To wrap up,
that's huge. Mel. Like, good job. Yeah. So that's like now that it's deployed onto the test net, and that's something that if those were public functions, I could go there and find a smart contract on the test net and interact with these functions.
Exactly, and let's test it. Like we're on Polygon scan, Amoy. This should have. Okay, perfect. Here's the contract creator. It's E8DV, which should be same as this. Perfect. Seems like it was almost a minute ago. Makes sense. So yeah, this is the beginning. The first session, we speed run through a lot of things. The basic idea was to get us at least somewhat used to this Solidity, blockchains, hashes, signatures, and all of this crazy stuff that we might be using in our day-to-day. We might not be using them that much, but we'll definitely need to know what they are used for, or at least have the concept of why is it needed for our future sessions. So right now we did a basic contract deployment. It's a very simple one. It's just a storage contract. But for next session, we will dive into ERC20 and ERC721 and deploying it live with a front end where we can mint tokens easily. We can even upload some NFTs. And before we close, we need the challenges. The challenge, the first one, the community one. Remember, it is all about you sharing your idea with us. So this is something that you need to post on Twitter, on LinkedIn, whichever social media that you want, and tag us at Dabl Club so we can give you some feedback and also share it with other users. And this idea you can get started on this challenge. The second challenge, we will be uploading it soon. It's going to it's all about you setting up your environment. So we will be using Scaffold ETH for this for next session. Scaffold ETH.io. So I'm going to be sharing the QR code. So you can like scan it very easily. And follow the docs, please. Follow the docs. This is something that you will need to start getting used to, because we will ask you for the challenge number 1 for you to upload your cloned Scaffold ETH to project to a public, a pull request on GitHub, so you can get started on this. We will be sharing also a small guide on this, like what do you need to do step by step, and a small video of you setting it up. For people who have Windows, this is very important. Please install Windows subsystem or Linux, because it's going to save you a lot of headaches, a lot of headaches. And it's very easy. Like back in my day, I don't know, back in my day, but like 4 or 5 years ago,
it was rough.
Windows 10, Windows 7, it was horrible. Like I don't think Windows 7 even had it, but Windows 10, yeah, it was like a lot of mess. And right now it's just a command and you can get it running. Let's see if somebody has an issue with Windows or would like me to help us like run a live demo on how to do it. We can record it and publish it for anyone. If anyone's on Windows, we would love to help you. It's gonna take us like 20 minutes. So yeah, that could be also helpful for others. Or yeah, but definitely if you're Windows, you have to do this. And for next session, we will be running with Scaffolded 2. We will publish these requirements for the next session. We will be using code. We will be using Cursor or Windsurf, whatever you are used to. I would recommend Cursor, but don't worry, we will send you all of this information. Please make sure to sign up on the application form, because that's the way that we will be contacting you for all of these updates, all of these guides or quick tutorials, and any other content is going to be published on Twitter, of course. But for the best content, the guides, just fill application so we can send it to your email. And yeah, that's a wrap for today. Like I said, get started with your first community challenge with your idea. We want you to publish it from here to Friday. And the social challenge is going to be also giving some feedback to the idea, so you can kill 2 challenges in one. And we will be showing a leaderboard of who has done what, so you can keep track of who's leading the challenges, and who knows, there are gonna be some surprises at the end. So that's all for today, guys. Kale, so how was it? We've seen some things that we didn't see. We kind of brushed
I love it
before.
I really like this. It's really, we've been watching such a maturing in our space with so much abstraction and so many like no code tools and all these lightweight things that sometimes you almost get too far away from the fundamentals. And it's one thing to build for users and the ease of use for them, but if you're going to be the builder, you've got to know what these things do. You got to know how these cogs turn. You got to know how all this works. And so it's really fun to kind of just start here at the bare bones again and just dive back through it. I want to answer this question here from Nick. He's wondering about that application form for like an easy link to it. Guys, the easiest way to find it is to go to our Lemonade calendar. And so that's at lemonade.social/s/Dabl. And you'll see the calendar and the times for all of our future coming DevCamp sessions. In the description of any of those sessions, you'll find the hyperlink to that application form. That's the easiest way for you to find it without having to drop this ridiculously long URL at this particular moment. So that's my recommendation, is make sure you guys check out our Lemonade calendar. That's the easiest place to find our upcoming sessions, get them added to your personal social calendars, as well as find the link to the application, so that way you can get that filled out. And then we will be hooking people up together in little work teams if you choose the option that you're okay working with friends. We saw some great results and saw some cool projects that are still being worked on today out of our January agent camp for people that were willing to collaborate with each other. So don't be shy. Now's a great time to try to learn from other builders and help each other and teach each other, as well as connecting with us each one of these sessions. This was great, Mel.
Yeah, thanks a lot, Kale. Thanks everyone for joining. Super fun, and it only gets harder from here. I'm not gonna lie. Like this was a lot more theory and a lot more, getting your feet wet, especially for people who hadn't come into this blockchain space. But next session is gonna be all about Solidity code and using the goodies that Scaffolded 2 comes with, so we can start like using a front end that's gonna enable us to debug a little bit our smart contracts. but it's a very important session because we will be going through some basic stuff like setting up Vercel, setting up your GitHub, how to enable these deployments automatically, which is super simple. And for you to get like the boring parts of DevOps and things that sometimes you might have never done it. It's easier than you think, but it's all about joining. And yeah, code is gonna get heavier. We're gonna have to start reading more documentation, but we're all gonna do it together. We will have additional resources. So yeah, invite your friends, invite anyone that you know that wants to build a token, wants to build an NFT, wants to build a wallet. We will get that far on week 3, but you need these fundamentals so you can stay on top of what's happening. And especially next week when we are going to be using Uniswap, Circle, and some ERCs for deal generation, we're going to be diving into crazy stuff.
Definitely going to get more difficult. You're not kidding. Just a reminder too, then, with that in mind, the easiest way to get like collaborative support and some answers to questions you may have outside of either our office hours or our live sessions is to join us in our Telegram chat. It's the most active place where you'll find us. You can jump right in there with a shortcut of dabl.chat, and it'll plug you right into the Telegram group. But you can also just go to dabl.club. That's the landing page you see right here. And you get that Telegram chat button right there in the center. You can hop in there and we'll have a dedicated topic. It's related just to dev campers. And that's usually the best place that we see dev campers working amongst themselves, getting answers and questions back from Mel, myself, or Colin, or anyone else from the team. And so that's where I would recommend that everybody make sure that you hop in that Telegram if you're not already in there. I see a lot of familiar names in our chat today, so I'm very just appreciative of our Agent Camp alumni and Dabbler community that's already been demonstrating that they want to hang out and learn with us. It's a very active community, so I'd recommend that you jump in there so that way you can get any support that you may need as things get more complicated. All right, Mel, well done. Day 1, DevCamp in the books. 5 more sessions to go. We're got lots to learn. I'm going to be jumping out of here, uninstalling my WSL setup in Windows and reinstalling it so I can make sure I remember how to explain that it goes smoothly. And then I think I'll be doing my social challenge and even playing a little bit in Remix today.
Let's go. Yeah. And like I said, the idea is what you start with. And trust me, it will change. Don't worry about it. Don't worry if it's rough, if it's like, if you don't understand it or somebody else doesn't understand it. That's exactly the point for you to get better at it. So yeah, let's just dabble on it and share it with friends, share it with other people, build in public, and share what you learn also, because it's really, really helpful for us to see what you're learning or even what you are not learning. Like, hey, I'm not getting this. Even tag us and we will be there to help you.
Absolutely. Dabbling is better with friends. All right, everybody, have a wonderful day. Go get some lunch. Let all this percolate. All these recordings will be on our YouTube page. You can also find them on the Dabl Club X page as well. So you can watch this and slow down and rewatch some of these particular sections if you have any specifics. Otherwise, catch us in the Telegram, catch us in the social channels, and we look forward to seeing what you'll build.